Hey, science peeps. This is Miss CG, and today we're going to talk about the scale of the universe, just how vast not only is our solar system, but is the entire universe. And can we really comprehend how far away and how vast things are when we talk about our solar system and the universe? So, one of the first things we're going to talk about is a word called parallax. And parallax is what astronomers use to measure the distances of nearby stars. And of course, that term is relative, nearby. They're still millions of kilometers away. So let's do an activity here and let's see if we could figure out how astronomers measure the distance of these nearby stars. So it says here to hold a finger about half an arm's length away from your face, as shown in the picture with this little blue alien there. Hello. And it says switch back and forth between closing your left eye and your right eye and watch how your finger appears to move against the background. Now, is your finger really moving? No, it's just your perspective, the perspective because your eyes are a couple of centimeters apart. So when you close one eye and open the other one and vice versa, your finger appears to move because of the perspective that you're seeing it at. Now, try something else. Hold your finger really close to your face and do that. And the appearance of where your finger moves seems to be like a big distance. Now, hold your finger very, very, very far away, as far as you can. Stretch your hand out all the way and do the same thing. And you'll see that your finger appears to move a shorter distance apart. So the same thing is true for parallax. The closer the star is to our perspective, the easier it is to see that change in distance and to measure that distance than when the stars are very, very far away. So to answer our question, why does your finger seem to move and how is this related to the parallax of stars? Well, your finger seems to move because, like I said before, your eyes aren't in the exact same spot. We have eyes that are a couple centimeters apart. So it's really the perspective of your eyes, not your actual finger moving. And then the other question said, how does this tell us how scientists can measure parallax of stars? Well, in the same way that our eyes are in different spots, when the Earth is in different spots as it makes its orbit around the sun, okay, we can then measure that difference in distance, that difference in perspective. So if you take a look at the picture down here, we see the Earth in January is in this position where my cursor is. And then in July, it's in a completely opposite position. So just like you opening and closing one eye or the other eye, that's the same kind of perspective that scientists, that astronomers can get when they look at the same star from two different perspectives. So in this picture, it shows you that when the Earth is on one side of the sun in January, and then it travels 6 months later to the other side, that's basically 2 astronomical units away. And we learned last lesson that 1 astronomical unit is 150 million kilometers. So this is millions of kilometers of change that we have to get a perspective on this one star. Now, how do you actually calculate parallax? I don't expect you to understand that and to know how to do that. One of the activities that I have you looking at today is this interactive activity about parallax. One of the things that you have to do, or that I asked you to do, is to read the introduction here. Now we go to the second paragraph, and it says, the method to use was obvious when they're talking about how to measure parallax. The method was trigonomic parallax, so using trigonometry. So you haven't even learned about algebra yet, let alone trigonometry. That's not until high school. So I don't expect you to know how to calculate parallax. I just want you to understand the concept behind it, that it's because of this change in perspective. That's how we can tell the distance of nearby stars. And again, the further the stars are away, the harder it is to tell that distance. Okay, so another vocab word that we have here is the universe. So the universe, astronomers define it as all of the space all of space and everything that's in it. So planets, moons, stars, planetesimals that we learned about last lesson, comets, meteors, everything that you can think of. Now, the space is so vast, and when we start talking about numbers here, these numbers start to get very big. So scientists use, and I'm going to move on to this next page here, use terms like light year, and they use math that is called scientific notation. So a light year is the distance that light travels in 1 year, and that's 9.46 trillion kilometers. That's a lot of kilometers. So when we talk about that this star is 10 light years away, you start to get an understanding of how far away that star is. And so then where does scientific notation come in? Is instead of writing all these zeros after a number, which will be sitting here for an hour writing a bunch of zeros, we use scientific notation. Like we say 1.2 to times 10 to the power of 3, or you can say 8 times 10 to the power of 12. So that would be 8 with 12 zeros after it. So just using scientific notation shortens, is like a shorthand for those large, large numbers. So again, to put into perspective the vastness of our universe, this is a picture, and it's not a picture of our solar system. It's a picture of our galaxy, our Milky Way galaxy. So this is not the sun in the middle. Okay. This is a nebula. Okay. It's a younger patch in here. And if you take a look around, so we're a spiral galaxy. You can see the spiral here. Our solar system is all the way over here at the end. So we're not even the center of our galaxy, of our at all. We're way over here on the end, like a little speck in the whole array. And there's all other kinds of solar systems all throughout all of this. And then this is just one galaxy in millions of other galaxies out there in the universe. So now think about that. How tiny we are compared to the vastness of all this space, and why we have to use things like light years and scientific notation to explain that vastness. Okay, so let's just answer these last two questions. What is scientific notation? And how is scientific notation useful for astronomers? So I think I really hammered home this concept that scientific notation is just a shorthand or a shortened way of writing these vast, large numbers. And why is it useful to astronomers? Because it puts into perspective how far away these things are, how vast it all is. It's as simple as that. Here's a really cool series of photos that I found. This is our galaxy, the Milky Way, and this is our nearest neighbor galaxy, the Andromeda galaxy. Now, this theme of gravity, we've been talking about it since the beginning of the semester. Gravity is always pulling things toward each other. So, same is true with galaxies. These two galaxies are massive. They have massive amounts of matter, and they're being drawn toward each other. So, a little look into the future. This is it today. If you were to go out somewhere where there's no light pollution, you would see this arm of our Milky Way galaxy. And right out here is the Andromeda galaxy. In about 2 billion years, we'll probably be on another planet by then. But it says by this time, the Earth's oceans will have mostly dried up. And you can see now how these Andromeda galaxy and the Milky Way are getting pulled toward each other because of this gravity pull. In 3.75 billion years. Okay, so we're going to be similar to Venus at that time. Venus has all volcanoes and it's hot and very inhospitable. So we're getting pulled closer and closer toward each other. And then in 4 billion years, we're going to be neighbors right there on top of each other. But again, to put into perspective the vastness of our universe, it would take 4 billion years for these two massive objects or these two galaxies to even come this close together. And that's a long, long time. Okay, let's go back to our hyperdoc. We just did our activities here. If we want to go down here, your individual practice grade for today is to watch this video, a crash course astronomy, and it's called Distances, and it's going to talk a little bit more about parallax, give you a different perspective on it, no pun intended. And then there is a Google form for you to complete as well as you watch the video. The interactive website was the one that I just showed you about parallax, and read a couple of these tabs here, but this is the page that I want you to play around with. So again, you want to X out this box right there. So what it's showing you is that depending on the kind of telescope that you're using, a home telescope doesn't have a very high resolution. So you can see how this picture, you don't see a lot of detail. And as you go to your research telescope and then your space telescope that's already in orbit, you get a lot better detail. So the better detail, the better the telescope, the better you can tell and calculate parallax. And then the other thing is the closer you are, again, the distance matters. So this blue object is the star that as the astronomer you're watching, you can see it moving as the Earth goes around the sun. But if you get closer to that object, you can see that that star, it seems to move a little more. It's not really moving though, it's us moving. But the further that star is away, okay, the less it seems to move. So the harder it is to really tell that distance. Play around with it a little bit. You can even play around with the orbit. We are really one astronomical unit around the sun, but you can change the size of your orbit, and just so you can get a better idea of what parallax is. Okay, then moving on down to the next activity, I would like for you to watch these two videos. One is called Watch This Guy Build a Massive Solar System in the Desert. It was actually a few people, but it's really cool to see how they measure the distances, and again, how vast they're trying to do it to scale. Because all of these pictures that you see right here, they are not to scale. Whenever you see pictures of the solar system, they are never to scale because you would never be able to see it in one spot like you see it here in these pictures. And then there's a second short video, the solar system to scale. And again, it's just showing you some very different perspectives on really the vastness of our solar system. There's a very cool website. This is the site here. It says, visit this site and get ready for a long ride. And you have to scroll at the bottom of the screen. So this is the website. And what you do is you start clicking this, and you're going to be sitting here for a while, but it's kind of fun too. And you scroll and you scroll, and we're not even at Mercury yet. We started at the sun. It says pretty empty out here. At some point, we eventually get over to the first planet. Here comes our first planet. Thanks for the heads up. And we finally have hit Mercury, and they are showing you this to scale. Look how tiny that is. It's like a pinpoint there. And you can just keep at the bottom, keep scrolling to see how vast and how long it takes to get there. That's the long way. You can always see there are some shortcuts. I'll let you play around with that up here to see how to get to the other planets. Okay, and then again, remember to study for your vocabulary quiz, which is tomorrow. So look at those flashcards on Quizlet. And then I have some optional reading for you to do. One is very cool, something that's coming up April 29th. There is something big headed our way. Don't worry, we're not in any danger. But if you want to find out the details of that, go to this article here. And then just a couple days ago, all the planets, if you have, it's been very cloudy this past few days, but the planets were all lined up. There's a picture of it in this article, and that happens from time to time. So does that mean anything? I don't know. Why don't you go read the article, see why that happened and what it looked like. And if you have a telescope at home, go for it and go see if you can catch some images of those planets. Venus is always super bright in the sky, but take a look at some of our other planets in our solar system. All right, well, that's all I have today. I hope you learned something and enjoy the videos. CG out.